if t is equal to 6, x is equal to 3, and let's see, that's a minus 2, which is a minus 6/3, isn't that 14/3? Now, I think that 20/3 is 1/3 short of 7. You think that? I'm only doing that so I can graph it. I'm trying to graph it the easy way, huh? 17/3 is what?
1/3 short of 6.
1/3 short of 6. 14/3 is 1/3 short of 5. Seven is x is equal to 4, and y is equal to 13/3. Did I get that right?
11/3.
That's a minus 4/3. That's 6. Let's see. Hold on. 7. So it's a minus 7/3. Yeah, I think that's 13/3, isn't it? Am I right? Is that right, Virus?
Yeah.
So this is 1/3 more than 12. 1/3 more than 4. Does everybody understand that this has no mathematical significance at all? The sole purpose of this is so I can put some dots on that graph. So, t equals 0 is the point minus 3/20. Coming at 8 o'clock.
This is my first time I'm late. This is ridiculous. No wonder.
If t is equal to 0, I get x equal minus 3, y equal 1/3 short of 7. So x is equal to minus 3, 1, 2, 3, 1/3 short of 7, 10, 9, 8, 7. So, can I say it's about there? Everybody agree? Okay. T equal, so this is the point T. Oh, after all that work. Okay, this is the point T equals 0, is it not? Everybody agree? And then t equal 3 is the point 0, 17/3. So 0, 17/3. 1, 2, 3, 4, 5, 6. There's 16 6 is 18/3, so I need a point about there, don't I? So this is T equal 3. Now, T equals 6 is 3 14/3. 1, 2, 3. 1, 2, 3, 4, 5. Right about there. And this is T equal 6. Everybody agree? Okay. Now T equals 7 is 13/3. This is going to get a little dicey. T equals 7 is what? It's 3. No, it's 4 13/3. 1, 2, 3, 4. 13/3 is 1 more than 3, right?
More than 4.
What?
1 more than 4.
13/3 is 1 more than 4. 1, 2, 3, 4. About there. Everybody agree?
Did your T equal 0 be moved down a little bit?
Yeah, I'm going to have to work on it to make it a line, huh? This is T equal 7. Okay, now T equals 0 was what?
1/3 short of 7.
20 minus 1/3, 20/3, so that's 1/3 short of 7. So 1, 2, 3, 4, 5, 6, 7. That helps it, doesn't it, Seth? I should move that down to there, shouldn't I? Is that right? 1, 2, 3, 4, 5, 6, 7. That makes it look more like a line, doesn't it? A line, what did your geometry teacher teach you? A line goes infinitely in both directions. But remember, we're not interested in a line. We are only interested in this. Is that right? So I'm not going to draw the whole line. What I'm going to do is I'm going to try to draw a line through here. And that's all I'm interested in. Okay? Now, what's left on the graph? What's left to do on the graph?
Direction. Direction.
Direction. Very good. So don't I have to put something that says that it's going like that? Everybody get the idea? Now, why is that important? Well, suppose that my friend in the motor lab in Detroit is studying change in oil pressure when you let your foot off the accelerator. And suppose that is a graph of how oil pressure goes down. We know in that case it would probably be a slope to it, right? But we don't care for our purposes. And suppose he saw something that happened between that little interval, and suppose he wants to study it in depth. And if he wants to study it in depth, the easiest way to study it in depth is what? Just start where you want to begin and do it in reference to time. And that is, if that's supposed to be, suppose this is supposed to be the ideal case right there, and then suppose that he's got a stopwatch, or that they've got one of those timers on a screen, and suppose they can slow it down, and suppose they can record those. Get the idea? And the timer on the screen would be from the time you started timing until 7 seconds later or 7 minutes later. You get the idea? And you should have already seen some of this in physics. There's an interesting one. There's the standard physics problem of a child pulling a wagon with a rock in it, and as the child starts out with it straight like that and lifts the handle a little bit as they walk. And right here is t equals 0, And that's what we're saying. What parametric equations allow you to do is to change an x-y equation to a function of time. Questions? Anybody? Anybody? Okay, that's the last of that. This is section 11.2, and this is the calculus of parametric equations. Okay? Now, let's suppose that I have x equal some function in t, and y equal another function in t. And you remember how on Friday I just wrote something with t's in it? Isn't that what that means? Does everybody agree? And let's suppose that I've got some parameter of t where a and b are numbers. You understand what I'm saying. What I'm telling you is that I don't care what those numbers are right now, so I'm just going to call them A and B. It could be 0 to 7. You now have 3 cases, don't you, and 1 problem of what t could be, huh? So it doesn't matter is what I'm saying, okay? Now, I want to find this. What's that called? Give me another name for that. That's exactly the name I wanted. You heard Travis as he yelled out the answer. The first derivative? Isn't that the first derivative? How about the slope of the tangent line? How about the instantaneous rate of change? All that stuff, right? The rub is, our problem is no longer in X. And in fact, I don't even know what the equation is in X. Nobody gave it to me. So, without me showing you anything, what's one way to do it? What's one way to do it? Well, let me show you. Let's suppose isn't that the same thing as I had above, only it's an example? Is that right? And now you want to find the slope of the tangent line. Find M at I'm making it up, hang on. At t equal 0. But you don't know how to do it. Except I think you do know how to do it. Here is one way. One way is, I know that if y is equal to t minus 1, then doesn't that mean that t is equal to y plus 1? Everybody agree? Okay? So now don't I have x is equal to 2 plus 4 times y plus 1. Do you think that's right? So isn't that then x is equal to 2 plus 4y plus 4? Or how about y is equal to 1/4 times x minus 6? Well, let's see. First thing I'm going to do is, that's 6, and I'm going to move it over to this side, right? And that leaves x minus 6 over on this left side and 4y on that side, right? And then I divide and I get x minus 6 over 4 is equal to y. And I wrote it like this because for some reason, I'll bet, throwing Ms. Voss in with us, all five of us sort of like to see Y on the left-hand side. I know I do. Okay? Now you tell me. Seth, can you determine what that is now? Travis, can you? Bowers, can you determine what dy dx is right now? Yeah, I think I can. I think this is equal to 1/4 x minus 3 halves. Is that right? So, isn't this equal to what you and I, for a while, have been calling y prime? Is that true? Everybody? So isn't this equal to then y prime is equal to 1/4? Period. Not at x equals 0, at x equal everywhere, right? It's a line. Everybody agree? So that's one way. And this one way is by eliminating the parameter. Is that right? Okay? Now, the directions on the test are going to say, find dy dx without eliminating the parameter. If you do it that way on the test, I'm going to mark it wrong. Is that plain enough? You'll get no credit. Why? Because once I've showed you that trick, you don't have to learn anything new, do you? And I'm going to insist that you learn something new. Okay? So, what I'm going to do is, I'm going to say, you know what that is? Y'all quit looking at it like it's Greek. You know what that is? That's the chain rule. That's the chain rule that you learned in Cal 1. Is that right? Okay. You take the derivative of y with respect to what's inside the parentheses, and then you take the derivative of what's in the parentheses. Isn't that the chain rule? Everybody? Okay? So what I'm going to do now is, if that's true, what would dy dx be equal to? if that is true. No calculus, algebra. Algebra.
dy dt divided by dx dt.
Anybody see any rocket science there? Don't I have, if I had 4 is equal to 2x, wouldn't I divide by the coefficient of x? So, didn't I just divide both sides by dx dt? So what I'm telling you is, this needs to go on your 3x5 card. And I know that now to work this problem the other way, I know that dy dx is equal to dy dt divided by dx dt. But in our problem, what is dx dt? In our problem. What's the derivative of x with respect to t? What? 4. Everybody agree? That's 4. Huh? What's the derivative of y with respect to t? What? 1. So isn't this equal to 1 divided by 4? Pretty slick, isn't it? So what I'm going to do is I take this and I go up here and I notice that, and that's equal to that, and that is equal to that. And this is equal to that, and it's equal to that. Questions? Okay? Isn't that pretty easy? All right? Let's work an example. Though we just did, this was too easy an example, but it made my point, didn't it? This is example 1 on page 637. Isn't that the 3 parts I need to define an equation? Everybody agree? And I want to find, well, hang on, I'm making this up. I want to find the the velocity and acceleration at t equals 0. First thing you look at is you look to see, I don't think that's in the book, is it? I don't think they asked that. They asked to find the tangent of the curve. Okay. Okay. Let's stick with that example. It's the same thing. Isn't the tangent of the curve the same thing as the velocity? So I'm going to stick with the problem in the book for one time. So I want to find the slope of the tangent at t equal 1/4. Now t equal power 4. And unlike them, at this point, I don't care what the XY point is. Could we get it real easily? Yes or no? Wouldn't we just put 1/4 in the place of t? Is that right? I pi over 4 in the place of t. Okay, so the slope of the tangent, you and I both know that is dy dx. But now we know that is dy dt divided by dx dt. But dx dt is equal to what? What's the derivative of the secant? Secant tangent. Secant t tangent t. And dy dt is equal to secant squared t. What's going on? Oh, Dr. Thomas.
Yeah.
Turn the key behind you, Ed.
Oh, okay.
Okay? Thank you for doing that, Beth. Please do that for Dr. Thomas. Okay? This then is equal to secant squared t over secant t tangent t. Everybody agree? And that looks like this then is equal to secant t over tangent t. But that is equal to 1 over cosine t times cosine t over sine t. See if you agree with that. The first part, the 1 over cosine, you wouldn't argue with me about that, would you? That's the secant, is it not? That leaves 1 over tangent, right? Everybody agree? But 1 over tangent's the cotangent, and the cotangent is equal to what times what? What over what? Cosine over sine? Is that right? Am I right, everybody? I did that, I've told you this a long time ago, I did that because I don't want to fool with the others, huh? And plus, I sort of had a hunch that nice things were going to happen. So, this is equal to 1 over sine t. So, at t equal pi over 4, dy dx is equal to 1 over the sine of pi over 4. Is that right? But the sine, but that's equal to 1 over the square root of 2 over 2, which is equal to 2 over the square root of 2. Which is, and then if I multiply that by square root of 2 over square root of 2, I get 2 times the square root of 2 over 2, which is equal to square root of 2. So, would you say that the slope of the tangent at t equals pi over 4 is square root of 2? And I would also say that the particle at t equal pi over 4 time is moving at a rate of square root of 2 and then units per second. I didn't call it feet, centimeters, I just said units. Everybody okay with that? Okay? Now, everybody okay? Okay? Now, same problem. We'll just call it seconds, okay? What's the acceleration? Well, how do you learn what is acceleration, y'all?
It's the second derivative.
Second derivative, right? So, would you say that y double prime is equal to the derivative of y prime? Would you say, isn't that the way you were taught to take it? I cannot take a second derivative. I can't just jump up and take a second derivative. I have to take the first derivative and then take the derivative of that, don't you? But isn't that equal to the derivative with respect to x of y prime? Is that not saying the same thing? Yes or no? But then remember that dy dx is equal to dy dt over dx dt. Everybody agree? Well then, isn't this D? I'll write it and you tell me if you think that's true. Is that true? Here's what I said. I said that y double prime is the derivative of y prime, right? So wouldn't I just put y prime right here where y is? And if it is, doesn't it go right there? Right? And does it have anything to do with dx dt? Nothing. Follow? Wouldn't you agree that's pretty easy and it just sort of makes sense? Okay? So what we're going to do now is we're going to say, okay, then, let's see, y prime turned out to be 1 over, cosecant t, right? It turned out to be 1 over sine t, didn't it? Is that right? Which is cosecant t, huh? Everybody agree? And the reason I'm calling it that is because I want to know what dy prime dt is. So isn't that asking you what's the derivative of cosecant t with respect to t? What is it? What is it?
Negative cosecant t cotangent t.
Very good. Thank you, Seth. Negative cosecant t cotangent t. Is that right? Everybody agree? But that isn't going to get it and let's see, then I already know dx dt, don't I? Dx dt from the previous page is secant squared t, right? Secant t tangent t, huh? Is equal to is that right? And we found that that was equal to, didn't I do some work on that? No, I didn't try to change that, okay? Okay, so now I've got minus cosecant t cotangent t over secant t tangent t. Everybody agree? But I think that's the same thing as minus cosecant t cotangent t times cosine What do you think? Does everybody agree with me? Iris? do you think, Byers? Do you see where I got it? If you don't, tell me. Okay. Now, enough of this. This is equal to minus 1 over sine t times cosine t over sine t times cosine t times cosine t over sine t. Well, it won't let me move. All right, Byers, tell me what it is.
Cotangent cube.
Turn up the volume a little bit.
Cotangent cube to c.
Let's leave it in sine and cosines.
Okay.
What's the numerator?
Cosine cube t.
Very good. Cosine t times cosine t times cosine t times 1, right? Does that look like cosine 3t over sine t times 1 times sine t, huh? Sine 3t.
It's negative.
Hmm?
It's negative.
And a negative in front of it, thank you. And I think then at t equal pi over 2, pi over 4, at t equal pi over 4, the acceleration is minus 1. How did I get that answer so fast? Travis, do you know?
Is 1 over the tangent of pi over 4 cubed.
Hmm?
Said 1 over the tangent of pi over 4 cubed. And
Yeah, that's one way.
tangent of pi over 4 is 1.
That's exactly right. Very good. Do you hear what he said? That wasn't my way. I told you I think in terms of sine and cosine, right? What Travis said is exactly correct. You think that way and you're in business, okay? I am not at all minimizing what he said. In fact, I did the same thing. I remembered a long time ago that for any multiple of 45 degrees, any angle that is a multiple of 45 degrees, the sine and the cosine are the same thing. So I just said that's something divided by that same something. And that left 1 to the third power, didn't it? Which is not a bit better than the way Travis thought about it. I'm just giving you another way to think about it. But if you hadn't have noticed any of that, wouldn't you have just put that in your calculator and you'd have gotten 1? Just don't tell me you had to do that. Please don't tell me you had to do that. If it's okay if you need to do it, it's okay if you want to check it. I just don't need to know about it. Okay? Questions? Okay? let's do one more, and then I'll think I did good enough on this, and we'll move on. This is example 2 on page 637. I want to say, find the second derivative with respect to y, of y with respect to x. Okay? Isn't that the second derivative? And remember me, I don't know how to take the second derivative. I have to take the first derivative. If x is equal to 1 minus t squared and y is equal to t minus t squared. All right? So don't we start taking derivatives of x and y with respect to t? Everybody agree? So dx dt is equal to minus 2t. Is that right? Dy dt is equal to 1 minus 2t. So dy dx is equal to dy dt over dx dt, which is equal to minus 2t over 1 minus 2t. What? Yep. Thank you. Did you see Travis waving, doing this? He wasn't calling for a curveball. And that is 1 minus, thank you Travis, 1 minus 2t over minus 2t. I could do other things to it if I wanted to, but I don't much care. I'm going to just leave it alone for now. Now I need the second derivative, right? Everybody agree? So that means that I need the derivative, the second derivative of y with respect to x, which is equal to the derivative of y prime with respect to x, which is exactly the way we do it. We take the derivative of the derivative. But that then is equal to the derivative of y prime with respect to t over the derivative of x with respect to t. Okay? But isn't this y prime? No. Where is y prime?
It's a dy over the dx, right?
Yeah. Isn't this y prime? Did I do that on the other one?
This is what gets confusing in the book.
Yeah, I did it that way. didn't write it. I said that that dy dt is equal to cosecant t. And that came from right here, doesn't it? Right? So I just didn't write it. And then I took the derivative of that first, and I put that in the denominator, so I did it the same way. Okay? So now I need y prime is equal to 1. Now I have reason to minus 1/2 1/2t minus 1. And no minus, plus right there. Do you agree? Does everybody agree? Ed?
My experience is that the book doesn't explain it very well, and it's easy to get sidetracked.
Well, let's keep it just sort of simple. And that is, all I'm looking for is something to substitute in right here and right here. We're not talking calculus here because this is already done for us, isn't it? Well, no, but at least y prime is done for us, right? You agree? Everybody agree? And what I did here, why did I rewrite it like that? What made me change my mind and think it is suddenly a good idea to rewrite it?
Don't want to do a quotient rule.
I didn't want to use the chain rule. I mean the quotient rule. I didn't want to use the quotient rule. I don't like the quotient rule unless I have to. I'm not afraid of it. I don't think you are. But why fool with it if you don't have to? Is that right? So I think I can take the derivative of this, the derivative of y prime with respect to t, pretty easily. I think that's a minus 1/2 times minus 1 over t squared, period. Have you by now decided that the derivative with respect to x of 1 over x is equal to the derivative with respect to x of x to the minus 1, which is equal to minus 1x to the minus 2, or minus 1 over x squared? Can you do that in your head now? I think I'm going to quit working it out, and whether you can do it in your head or not, you'll know how I got it, right? Is that okay with y'all? Okay? But doesn't that look like